Hey guys, I know you guys are like, what the hell are these slides? Yeah, so I made slides before actually. I have a few slides. I don't know why they use them, but I believe that these are a lot better than what the book will give you on IR, NMR, and UV. Like these are pretty good. Um, I wonder who made it. Okay, so let's first review functional groups. I mean, there's not much to say. Each of these have a different spec, right? So each of these show up differently on your IR spectrum. So I would know your functional groups just straight up, okay? So the electromagnetic spectrum, again, this is pretty important, right? So you see here with the shorter wavelength and then the longer wavelength. So the longer wavelength has a lower frequency, so they have opposite effect. This is usually what we're gonna see, right? Visible light is what we see. As we can see, infrared light, which is what we're gonna see also with IR. UV light is here. So you see how these two, though they're not as energetic as like X-rays and gamma rays, they're still pretty up there. So you need to know what wave number is. So wave number is pretty much this axis of your IR spec, okay? There is a lot of detail here, but we're not going to go over all of it. So yeah, just know wave number. Those are your wave numbers, and again, it's calculated through 1/centimeters. So so the formula for it is 1/centimeters, 1/wavelength. So the wave number formula is 1/wavelength. 1/light wavelength will get you that number. Yeah, so yeah. So these are more important for conceptually thing. So this just pretty much tells you why if you guys have any foundation in IR, you understand that some IRs look like very like this. You have some that are spiky, like you have all type of different looking IRs. And this is pretty much the reason why. Because each IR moves differently, even if it's the same shape. It's actually pretty cool. So each vibrational node will give you a different shape on your IR, because each node absorbs different frequencies, which is so cool. So guys, it's so cool. So the reason why you can see the different absorptions and like how much it go is due to the fact that even though these are the same molecules, simply the way that they are vibrating will change the amount of infrared light that it can absorb. Okay? So next we're gonna go over some peaks. I would know all of them that I'm gonna say here. These are pretty much everything that you need to know for your MCAT. All of these great peaks. Yes, shout out Cengage Learning. So I guess I'm just gonna look through it. Again, really, we don't need to talk about this too much. But again, like I said, do you see how it's a little blurry? But see how this is CH stretching, and then this is CH2 bending. That again goes back to here and here. So that's what that is referring to. So we're just gonna go through. I'm just gonna slowly just go through the slides so you guys can like take a look or pause or whatever as you look through what the different peaks look like. So each peak again they're all very distinctive. You can definitely tell each one differently. Sorry for it being a little blurry. These ones look a little better. Alcohols, and again, this is a huge one that you will see. I would know these. These are ones that a lot of people struggle with. So your primary and secondary means, you see the difference is your primary means you have 2, and then your secondary mean you just have 1. Okay. Tertiary mean you actually have no peak, and then ketone you have a very strong peak. And then a few more. Carboxylic acid, this one matters a lot. And then aldehyde, your peak actually shows up there. So you have both of those peaks. And then, oh my gosh. Okay, we're actually not going to go through all of these, but pause the video. And then realize I put so much. Yeah, I forgot I put practice problems on here too. So you see how like One thing about IR is you're not going to get the exact molecules. You can get like multiple different molecules. So like all three of these match this IR. The only way we could narrow it down is if we used NMR. So here's again the way some more peaks would look like. And then again, just to really, again, this is like very important. So really understand. And then here's a pretty good picture on all of them. Okay, cool. So next, let's look at NMR. So NMR is the way that we can narrow down structures. You see how here with IR, we still have like options. When you use NMR, you have no options. There's only one answer. It's pretty cool. It's definitely about different absorption frequencies as always, which is going to be a recurring theme here. So the N plus rule. So the N plus rule tells you how many neighbors something has. So like neighbors being hydrogens around. Hydrogens that are adjacent, okay? So it's like if you have no adjacent hydrogen, what does that look like? You see how, let's draw it here. Would be CH3, CH3, CH3. And you see how there's no hydrogens on this carbon. So that means that this would be a singlet, okay? And so on and so on. So let's say that we now turned this into a hydrogen. Now, this is a doublet, okay? And if we add another hydrogen, this would be a triplet. And then if we add another hydrogen, this would be a quartet, okay? And so forth and so on. Yeah, pretty simple. Chemical shift is pretty much just know your signals. Definitely know these. It pretty much will tell you where, like, things are on your NMR spectra. So understanding these can actually make it a lot easier to solve these type of questions. And then integration, so this will really tell you how many protons are around. So like if I'm looking at this and I see, okay, this is a 2H peak, then I know that it's, let's put this as R. You see how there is a carbon connected to two hydrogens, so 2H peak. And then this would be like a 1H peak here if it was like RH. And then do you see how this is a 1H peak here? And then it also has, remember, it has one dot, okay? So it's a singlet. One dot, I mean one peak, right? Like we said up here, right? When there's one, it's a singlet. Oh, this is exactly what we're talking about. Yeah, so pretty important. Again, this is something that you just memorized, but it goes up. So 1 solo singlet, 2 doublet, 3 triplet, and so on and so on. So on and so forth. So complex splitting benzenes are different. So definitely, if you guys remember ortho-para, I always remember ortho is when you attach to the second carbon. So I always say 1 2, because you count 1, 2. Meta, you attach to the third one, so I always say 1 3, because you attach 1 2 3. And then para, I always say 1 4, because you go 1 2 3 4. And then these are your different type of activating, deactivating groups in ortho-para. So just memorize what these are, what they do. So your meta directors are these guys, and then your ortho-para directors are those guys. And here is some more examples of, I'm guessing this is on the wrong side, sorry, but this is just some oh no, this is the right side. So let's go through this, right? So do you see how here 3H no neighbors. So that's that guy. So that guy's here. And then do you see out here we have a 2H, right? And let's count this. 1, 2, 3, 4. And we know that that's going to be a triplet. So this is a 2H with 3 neighbors, right? And again, neighbors meaning the amount of hydrogens around. So bam, 2H with 3 neighbors. So that guy, you always check it. I'm the type of person, check. And then we see how this is a 3H with 1, 2, 3. So meaning it has 2 neighbors, which is that guy there. Okay, so this is how I would typically break down an NMR. And let me I want to make it very clear. And then, yes, this red one. Okay? And then try this one on your own. Try to explain this one to yourself. And then try to explain this one to yourself. Last but not least, UV Viz. Definitely the least important one of all of these. So, well, not gonna lie, I've seen a few questions, but I've seen more in the others. But yeah, it's pretty much seeing where molecules are absorbing energies and changing states and stuff like that. This is very important. Beersol is very important. This is probably the most important thing about UV Viz. Definitely just know it. Your path length will always be 1 centimeter. I'm pretty sure. And yeah, memorize this formula, and then you can use it to solve for things. Yeah, again, this is just how UV Viz would look, and it's all about color, so it's all about how much you absorb, and then that's actually it. Woo! So that was a longer video, but that was a very, very in-depth dive. So we're finishing Orgo. We only have chapter 12, so thank you for staying to the ride. I would record chapter 12 now, but it's like a little late, so I'll record it tomorrow. I'll see you soon.